line of symmetry. So these are some old words from Unit 1. Some of you will remember, yeah. I almost want us to put an X for minimum. I mean, you don't have to, but we're not going to use it. You can, with your pencil, you can put an X next to domain and range. They're there, but we're not going to use them in this last time. So we're just going to try and focus on part of what you learned a long time. Because if we try and put it all back together again, for some of us, it's going to do the same thing we did early on, which is, okay, is it this one, is that one? So I'm going to see if I can do my best to just focus on some of the key ones here at the last part. Line of symmetry, which they need.
Who's excited for Saturday, Monday, guys?
Woo! Woo!
Line of symmetry.
What's Saturday, Monday?
Where you guys the front line?
The other one you want to mark is write down line of symmetry. What is that other thing? Oh, parabola.
It already follows
Parabola. Write down parabola in relation to the E version. For parabola, we're going to draw pictures and write down two forms of the equation that you get to know that's going to be a parabola. So for parabola, here's what I would have you start doing. Make a little XY plane. Someone described, there are two versions of the parabola. One is going to be the one we're going to really use, but what are two examples?
A U.
I heard a U, and she was drawing it, and what's the other version of it? Okay.
Oh, when it's
Half, but, say it again?
But I said that U.
All right, so we got the U. What I was trying to get is the reverse, the flip of it. What does the flip of it look like?
Upside down bowl.
Upside down bowl, a rainbow. The one that we're going to look at today is the upside down bowl, is the rainbow. In other words, go ahead.
Did you guys see the rainbow?
No.
It was cute.
It was cute.
Go ahead, put that one in, put that one in. And I know I'm using red, which I use also as my highlighter, but you're actually doing this with your pencil.
The writing utensil, the pencil.
So again, this isn't the only version of a parabola, but this is the one that we're using. Please write down the formula.
Oh, this is formula?
Yes, it's Y plus.
I'm going to do this short version, the x squared version. Now I am going to put in some of the other numbers for it. So this is the shortest version of it.
Can we just keep the y equals x squared for papers and not do this? Or do we do that too?
This one here, for this particular picture, to get an upside down one, must have that negative sign in front. If it doesn't have the negative sign, much like Anita said at the very beginning, you just get the regular U. A parabola normally looks like a bowl that opens up.
Oh, I get it.
But when they flip it upside down to do this rainbow, it must have this negative sign.
He said my name in the video, guys. I'm famous now. Thanks.
Those I'll look at later, but it'll start off this way. All right. Next thing, line of symmetry. How should I say it? Every parabola is symmetrical. It's like our bodies. If you were to cut it in half, the same thing would be on the left and on the right. That line, you could have, well, it's the outside part anyway. Where you cut it down the middle is called the line of symmetry. So the line of symmetry is where you cut the parabola right down the middle. That's regular talk, but I'm going to put it anyway.
Are you congruent to yourself?
Line of symmetry is the line. We will give an equation. Line that cuts. And I'm using regular talk here just because I want you to know it. That cuts parabola. And I'm going to put a dotted line here. And then I'm going to put the word line of symmetry for this.
Well, All of the alpha work. I'm so tired.
I'm still going to write down the definition, but I want you just to feel what it is. It's not anything tricky. Line of symmetry. And the line of symmetry has an equation. Anybody know what letter we use when we are given the equation for the line of symmetry?
X, Y. Oh.
Yeah.
X.
I heard
X.
that we had A, B, C.
Well, you paused. That was sure as X. You were like,
The line of symmetry's equation will always start off with X equals some number. In other words, here's the X line. If you want to tell me where this blue dotted line is, you say, oh, that blue dotted line is going to hit X right at, oh, X equals 7. Or like right at X equals 9. So the line of symmetry is always that.
If the parabola is, let's say, on side, would we still use the x-axis?
No. But that's why we're going to keep it specific to just one scenario for today. We're not going to do all the versions.
If we were to...
is the permit test for drive for like
Line that cuts
That's your question.
parabola in half.
Talk about logic.
It's
Use the permit test.
No, it's really
Permit test is easy. It's like
for the study?
Oh, yeah.
All right, write down where you get the whole definition for line symmetry that I'm writing. It's the line that cuts the parabola in half. Okay, write that down, write that down. If you haven't drawn the little picture, make sure you get the little picture down. All right, good, good. I see most of you writing. Good, good. You got it, got it. All right, just checking around and make sure you have it there. All right, if you haven't written, write your name, class, color on your paper. If you haven't written, all right, I see it, good. All right, good. All right, good, good. I see it. Right now. All right, let's get the rest. Let's back up.
She's not a good girl.
Can anyone say what the maximum of a parabola is?
Infinity.
Right here, highest point, good. Any other versions?
On the vertex.
Okay.
Or
Y equals something.
Vertex is going to be a part of that.
the highest.
It's only the
Spit it out. Spit it out.
I can't.
So here we go, maximum. We're going to put the highest point of parabola
Yes.
and slash, we're going to call that thing vertex. So thanks, Rob, on that one. So highest point. The minimum would be the lowest point, but we're not going to use that one for today because, again, my goal with all that they're going to ask you, they're going to give you this version. And I want you just to stay focused on this version. We can review some of the other things another time. For maximum highest point on the parabola, called the vertex.
But isn't the vertex
No.
the highest only if it's like a rainbow?
You're correct.
Well, yes.
It's conditional, isn't it?
Uh-huh.
But if we were to find the maximum of a regular parabola, then would it just be? But it would be vertex, right?
Say it again.
Like if we were to find the maxima of a regular parabola, how would we go about it?
Yeah, the vertex is the highest point or the lowest point. When it's the highest point, we call it the maxima. When it's the lowest point, we call it the minima.
Yeah.
Write that down, make sure you have it. The reason the words are important, of course, is they're going to... X-Intercepts, what do we have for that? Anyone know what X-Intercepts are?
When it crosses the x-axis.
Uh-huh. Crosses the X-axis. If I were putting something on here, if you had different colors, I would have you mark your picture with different colors. If not, this green dot is the vertex or the max.
I feel like this is getting a little too technical right now.
Yeah. I was trying to decide to do all the vocabulary, but you got to remind them what they're going to be asking them about.
I missed the vocabulary.
The X-intercepts. How many are you going to have? Yeah, you're going to have 2 of those X-intercepts.
Wait, is it just specifically on that line, or can it be like, let's say,
X-intercept number 1 and X-intercept number 2. Now on these performance tasks, always remember they start with the basic stuff, but then they put it into a scenario. They're going to put it into a word problem of some sort, and they're going to say to you, hey, please find the x-intercept. You're like, oh, okay, that's 1, 0, and maybe 3, 0. Then they're going to ask you, in this scenario, what does it mean? Like, what does this x-intercept mean in the scenario? For our purposes, they're going to be comparing the price that you have to pay for something on Cyber Monday and how much profit the organization is going to make. So just so you will have heard it once, and then we're still going to do it in there. For an organization to make the most money, they need to find their maxima, their vertex. If they know where the top of the rainbow is, they know what's the best price to make the most amount of money. And the best price is always going to be
40% off.
halfway between
That's right.
the first x-intercept and the second x-intercept.
Sorry, that's too
In other words, in math talk, for them to make the most money, all they need to figure out is what is their line of symmetry. What is that x that when they go shoot it right up into the air, it will hit the very top of the rainbow. So today what you're going to be given, you're going to be given a picture. It's going to ask you, hey, what's the largest amount of money, the biggest profit you can make? In math talk that just says, hey, what's the top of the rainbow? What y matches with the top of the rainbow? Oh, it's 50. No big deal. They'll ask you, hey, what does it mean if you're at an x-intercept? How much money on the profit are you making at this dot here? Anybody know that answer? And now we haven't gone through, but just see what you say.
What's the question again?
If the red represents your profit, how much money you're making, and the highest point up here is when you're making the most money. If you're a company, you're selling this stuff. The x-axis tells us what your price is. Hey, if we charge this amount, well, we'll make that amount of money. The question is, this red, when it hits this bottom line, which represents 0,
Dead.
the question then becomes, how much money is the company making? How much profit are they making when you're at this x-intercept, this green dot?
Nothing.
0.
Yeah, it's 0. With a company, there are 2 ways, when you look at the picture, that they can make 0 money. And here are the 2 ways. If you charge too little, then the amount of money it costs you as a company to make the product, to make the phone, to make whatever it is they're trying to sell to you. If you charge too little, you will make no profit. The same amount of money it takes you to make it is the same amount of money they gave you, so you don't get anything extra. Here's the other way to get 0. If you charge too much, the second x-intercept, then it's true no one's going to come and buy your product, and again, or too few people will buy your product, and again, you'll be at 0 profit. In other words, there are 2 ways for you to mess it up.
So how does that work?
The first x-intercept or the second x-intercept. So again, when you get into the problem, yeah, they're going to ask you, please find the 2 x-intercepts. You'll be like, oh yeah, obviously, ding, ding, I got 1 answer. But then the second question they're going to ask you is, hey, what do your x-intercepts represent? And they represent the 2 cases where you make 0 profit. In other words, they represent the 2 cases where the red line is at 0. There's y equals 10, 5, 4, 3, 2. When you hit the ground, 0, and you make nothing. So let's do this. X-intercepts, let's write those down. What did we say for that? That's where the graph is the red line, by the way.
Graph hits the x-axis.
Where graph hits x-axis. Red line in red.
Yeah.
You know what? Actually, put points where graph hits x-axis. Points. And then we'll actually go to
Do you have a lead pencil,
It literally has dust on it.
Thomas?
no. Points where graph hits. We're not going to write it down, but what is the y-intercept? We're not writing it down, but what is y-intercept?
The graph.
X-axis. Oh, just
Where y
Axis.
axis.
Yeah. So it's just the other thing, where the graph hits the y. But for this picture here, look at the red rainbow. Will the graph on this particular picture hit the y-axis?
Eventually.
For this picture where we're just stopping it
Oh.
at the x, this rainbow will not. And the picture that you're going to ask to evaluate today is going to be one quite similar to this. It won't be the kind that goes on and on forever and ever. Yeah. So let's see if we can get some pictures for us to start evaluating. Then we'll give you a question quite similar to what you're going to work on the performance task. Then we'll give you the performance task to get you to get as many points as possible, knowing that some of us will still have to fix it later on. All right. So any questions on these? Everybody has it written?
Yep.
All right. All right. So let's see if we go to the next page then. All right. So it begins.
What do you do practice?
Step one here is trying to produce, for those who are talking hold, step one, we got to try and produce a picture. Now, for today's assignment, we will ultimately do it on the computer. One picture they're just going to give you. The other one, you'll have to punch into the computer. For this one here, let me have you do something really fast. Please, below the 1, write another 1. We're going to get 2 X-Intercepts automatically. Please, below the 9, write another 9. To get 2 free X-Intercepts to draw your picture, here's what you do. All you do is, if it's given to you in factor form, to get the X-Intercepts, it's always the same number, opposite sign. The same number, opposite sign. So the question is, well, when I draw this rainbow, where are they going to touch on the X-axis? Say one of them.
-1.
-1. And what's the other one?
+9.
So what you're going to do on your x-axis, and this is only when it's in factored form, it's a freebie. Now again, if we have computers, which we have in the back, which we will use, I just want you to be able to at least do part of it without the computer. What you're going to do now is going to count up, find +9, hopefully they put enough squares, and -1. I'm going to show you also how to get 2 other things about the computer. One of them is going to be the line of symmetry, which is going to be halfway between the 2 dots, the 2 x-axes. And then we're going to see if we can help you get the, what's that thing called, the maxima, the vertex, without the computer. So let's see if we can do that. Step 1, hey, let's put in those dots, -1 and +9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have my 2 axes. I know where I'm not going to make any profit. So right now, I'm going to put the word price along the x-axis. In other words, for today's purposes anyway, we're going to say this is the price. At -$1, I don't know what kind of price that is. It doesn't quite make sense for this, but still we use it. No profit over here. Whenever we draw this rainbow, if you charge too much, $9. I'm not sure what $9 they're charging it for. Whatever it is, it's too much. Not enough people are going to buy. It's going to be 0 there. So along this line, I'm going to put profit. How much money are all the companies going to make today, and how much did they make on Friday?
Holy crap! Look at the folder for this class. Tell me something this.
I see. Nice and easy. We're at the end. So here's the other part. We need to find out when we draw this rainbow exactly where the highest point is going to be and how we can find that. Well, one thing I know is that this rainbow is going to be a mirror. About halfway here is where it's going to be cut. The question is, how do we find this middle point? Now, there's a mathematical way we could do it, or we can just count how many squares there are across and then cut it right in half. So count how many squares across. Once someone counts how many squares across? 10. All right, count 10. Now somebody would have thought, now, aren't there just 9? Because obviously 9 is the biggest number. But again, because it stops back here at the -1, we just count over. So if I were counting over, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Again, with technology, which is number 5, we just put it into the computer, and it'll give it to us. But again, just in case they give you the problem, say, please do not use the computer, I need you to be able to find it. Anyway, so what's halfway between this -1 and this 9? Now this part gets tricky. What I would do is just count over 5 blocks. So if I start here, I go 1, 2, 3, 4, 5. Now somebody would think, you mean just mark it at 5? No, because if we actually count over, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9.
So 4.
Yeah, so 4 is actually where we would cut this thing in half. And we gave a name for the point where we cut things in half. What was the name of that point? It was called the line of symmetry. In other words, at 4, when x is 4, we know that's where we would cut the parabola in half. I'm going to put line of symmetry after that. And again, as I was thinking about this, I was like, okay, all these words, line of symmetry, all this stuff. Where are they going to get lost with all the words? So I'm still going to try and put it down. Line of symmetry.
4 doesn't even look like the middle though.
Yeah.
It's,
That -1, remember?
Line of symmetry. Let's see if I can just abbreviate it. Symmetry. So let's make sure we know some things that are easy first. 4 is the line of symmetry. It's where we're going to cut it in half, but we don't know how high the thing goes. We're going to find out one more thing without the computer, and then we're going to see if we can start answering some of the questions. Line of symmetry. Let me draw this line. I want you to do the same. If you can draw a dotted line going up. Now, I don't know how high it's going to go, but I know half of the picture is on the right side, half of the picture is on the left. Here comes the question. How do we know that high point? How can we figure out how high this triangle is going to go? The answer is going to be this. We're going to put a 4 in the place of x. We're going to work out the first one, work out the second one, and multiply. Now again, when we're doing this on the computer, how will we find it out? We type in the formula, the rainbow will show itself, and then we just click at the very top, and it will give us the coordinates. For the purposes of this very first time, so you know why you want to use technology, we're going to figure it out. So how do we find out the highest point that y is going to be?
So would it be 4 minus 1?
We're going to put in a 4 in the place of the x on that one. Put a 4 in the place of x on that. Oh, that one. Which is going to create a problem that I'm going to fix. So let me fix a problem. The way they have this written is okay, except it's missing one thing to make the rainbow go up. Can anybody tell me what this equation is? Back row? We are going to put in a negative sign on this one. On the test, they will already have it there. This particular problem that was given to us, I'm just kind of bending it to make it look like what we need, okay?
So it'll be -4.
So this negative sign is just out front. The two parentheses are still there as they were.
So it'll be 1 minus 4 minus 1.
So far, what we have is this. To find out the tallest point, and I know I'm using a brain power on this, and I don't want to use it all because by the time we get to the actual word problem, you're like, whoa, my brain is dead. So here, I'll do this part for you. Just watch. Step 1, I'm going to do 4 plus 1 is a 5 for the first parenthesis. No big deal. This is outside. Just regular 4 plus 1 is a 5. The second parenthesis, does anyone know what 4 minus 9 is?
-3. That would definitely.
Negative 5. This is if we're doing it by hand. And then we just multiply 5 times 5. 5 times 5 is?
-25.
Negative 25. But because of the minus sign out front, the whole thing would wind up being positive 25. Now here's the bad part. Clearly there are not 25 squares. So we have to scale that thing so that we can get the 25 in there. If we did it by 2s, 1, 2, 4, 6, 8, 10, 12, 14, 15. No.
If you do it by 10.
15.
No. 5, 10, 15, 20, 25.
That'll work. No.
Yeah, it's a little low, but I guess 5. I guess 5 will do. Yeah, because 3 wouldn't allow it. So 5 it is. You will not have to scale it on the test. it will be scaled for you. So basically what we're doing is we're doing it the hard way so that they can see, okay, I see the first piece, the second piece, the third piece, so that when they give it to us, so we'll do it by fives. 5, 10, 15, 20, 25. $25 profit. So here's what's going to happen. We're going to put in our maxima right here at 25. When 4, which cuts it in half, then right above it will be the maxima. All right, let's draw that rainbow and connect it. It starts here, as best I can, right through there. Please write down the coordinates of the maxima, also known as the vertex. Okay, someone say what the first number is going to be and the coordinates for the maxima?
4.
4 is the x. So 4.
25.
25, good. So this goes all the way back to unit 1. Normally you find the domain range. We are not going to find the domain range, but do me a favor. Please write in the 2 intercepts. Write them as coordinates. You know -1 is one of them, but you need to write as a coordinate. -1 comma what, someone?
0.
All right, and then you can put in that other one. So we built the picture, but they're just going to give you a picture, and they'll ask you these same questions.
So it'll be a positive 9 or a negative 9?
You take it right off the picture. So now you're taking these off the picture. You were saying? Don't do anything with domain. We're going to leave that alone. Even though what you have asked about it, even though we don't need it.
What has been just closed bracket, -1 comma 9, closed bracket, right? So then what would the range have been? That's the only thing I'm just...
The lowest number to the highest number.
Oh, so 0 to 25?
What was the other X-intercept, please?
9,
You just look right on the picture and plug it right off. So part of the question they're going to ask is going to be nice and easy. Next to the Y-intercept, go ahead and put a little X just to show that we acknowledge it and we're not doing it. Next to the range, put a little X just to acknowledge that it's not that we skipped it, we chose not to do it. For yes, if there was a regular parabola going all the way down. But for the purpose of these, we're just doing this little picture because it's going to look a lot like what we're going to
No, I mean for the range, wouldn't it be...
Yes, you're right. What I'm saying is for this picture, where they actually have a stop. You're right. All right, Y-intercepts, maximum, minimum. Please write down the maximum. Why isn't it a minimum?
Because we're not doing minimum.
There you go. Let's love that. All right, go ahead and write down what the coordinates of the maxima is. Write it down.
Again, regarding which domain and if it's infinite or negative, it's always open bracket.
I said I wanted to try.
The maximum is 425.
I might have said the wrong number, so...
Now here comes the new part. We have this part. What does the maxima represent? Before you write it.
Highest point.
In a scenario of this scenario which says we're looking at prices and we're looking at the profit.
The max profit?
So that's all right. So say
Let
again.
him finish the question.
Yeah.
Jeez.
All right. So here comes again, and they kind of started
I
off.
want to know what he's gonna say.
What does the maxima represent? You gotta use these two numbers when you say it. But go ahead.
The maxima represents the most they can charge to get the highest percentage of people to buy.
And let's not say maybe the most they can charge. Let's say the price they can charge to get the maximum profit. Yeah. So again, for this one,
Breathe it out.
you write down 4 is 4 is the price to charge to get the maximum profit.
So 25? Or do you not use both numbers or do you use both?
You know, I guess you initially, but I guess in this guy, I guess we put the 25 in parentheses. 25 is the maximum profit on that part. X-intercepts. What does the X-intercept represent?
The price of being charged.
It's the price, but what happens at this price and what happens at this price?
We haven't started making the price.
I heard profit over here. Say it again.
So the lowest like price that they charge has zero profit, and the highest price that they charge will give them zero profit.
What's
Right.
what?
So I would say it this way: it's the two prices that you can charge that will get you a zero profit. Okay? So these are the X-intercepts. Two prices. Thank you, Carlos. Two prices. Two prices charged that get you a zero profit. And both of them, you see your Y is zero. That's your profit. Two prices that get you zero profit. I'm writing down my Y-intercept because I'm running out of space. I'm not sure where you're going to write it. Two prices. If you need to, down here, two prices that get you zero profit. That get you, that yield. I'm going to put yield that gets you out, so that gets you. That gets you zero profit. No money for the company. Now they're not losing any money, but they're not making any money on Cyber Monday. All right, so let's see what we have here. Let me see if we got all the things on the picture covered. We got the X-intercept, they got that. The line of symmetry, they got that. The line of symmetry gets you the highest point on the profit. They know what this number represents, the 425. How to get the maximum profit? They charge $4 for their product. If they want to be a non-profit organization, that is, they don't want to make a profit, they charge us -1, which doesn't make sense in real life, but for purposes of this picture, we'll use it, or the 9. Either one of those, no profit. Anything else? We're going to ask them. I think those are the main things. All right, let's find. On your papers, please circle the x squared. You're on 53, I believe.
55.
Page 55. On 55, please circle the x squared. Anybody know what the x squared tells you in this problem?
The line of symmetry.
Not in this case, but it tells you something about the picture, what this picture is going to look like.
Oh, it tells it it's going to be the positive problem.
You are right. For this one, we are going to change it again. We're going to put a negative sign in front of the x squared. Why are we doing that? We want it to be a rainbow to kind of mimic what we're going to look at in the final example. I'm going to start by putting my paper on the board, and then I'm going to have you all also actually try and get yours as your computers are getting started. Some computers are already started. Right. So if you have to switch out right away. That's why I'm going to start mine on the board. So, all right. So this picture isn't what we want. What can we change in this equation to make it go above the x-axis?
-2.
Yeah. The -2. We'll turn that into,
Zero.
so let's try it. It'll move the picture up. Let's see if it will do just what we need. It's high. Okay, no, that'll work.
You could do -0. It gets inverted above 1.
Yeah, let's use that. We'll just change the sign on that too so that we don't change the problem too much. You're right, we're going to change it to a +6. So for this equation, on your paper, do me a favor. Please change the equation
Well, now you have to use it
and making it a +2. Now, this isn't something you automatically do. We're doing this, the teacher's instructing you to do it. So when you get to the test and they have a problem, you use what's there. All right. if your computer is doing it, please try to fill in some of the pieces there. If your computer is not doing it and you need to see mine, you can use my picture to see if you can label. Now here's the problem with the Macs. If you were not using a computer, it would be hard to tell, is that 2.4? Is that 3? But again, because it's on with the computer, you know we can simply click the max, which now will not only tell you what the maximum is, it'll tell you what the line of symmetry is, which we didn't write on that other problem. That's what we missed on the other problem. Let's see if I can back up to the other problem. Let me back up to the other problem for just a moment. I don't think we put in the line of symmetry.
Yeah, we did.
Oh, we did, okay. X equals 4. Thank you. All right, do your best sketching in on this picture, what's there, and then answering the questions as best you can. So come around, just check and see what's on your computer. But again, if your computer isn't doing what we want it to, check on the board. Again, the person in the middle is saying Rob's case, make sure you look both right and left, that way. Alyssa's not alone, the same thing, Jose, so that Ron is not. All right, step 1, let's see if I can try and graph this thing. If I were trying to graph it, the 2 and the 2.5. All right. Sorry about the graphing on this one. This one again was with a strictly computer. You shouldn't have to, but I'm still trying to sketch mine. 1, 2, 3. It was a 2.5. What was the what were the 2 X-Intercepts? Well, let me write this down.
What is that?
Give me one of the X-Intercepts, please.
The X-Intercepts would be -1, 0, and 2, 0.
-1, 0, and 2, 0. -1, 0, and 2, 0. And what was the line of symmetry?
There's
There's 0.5. I think the next one we do is probably going to be weird in terms of graphing it as well. So I'm sort of glad we got this ugly one with small numbers, because the next one we're going to have, the number's going to be big. It's going to be almost real to life. In other words, the kind that you're going to see. So again, the maximum was what again? 0. I saw it 0.5 comma who? 2.25, and then the line of symmetry, the LOS.
X equals 0.5.
All right, so let's see if I can put this 0.5 here. If I were putting my dotted line, it goes up there. Okay, and again, here it is. Let's see if I can put that up there. The rainbow kind of goes through there. Some of your sketches are pretty good. Mine is hopefully as good as yours.
Wait, the line of symmetry doesn't have 2.25 in it? We're just going based off 0.5?
Line of symmetry is always just x equals one number, and that one number is the x coordinate. It's that number that will maximize your profit. Puts you at the top of the rainbow. What x puts you at the top of the rainbow? Well, does -1 put me at the top of the rainbow? Well, no. But if I get to this 0.5, it puts me at the very top of the rainbow, that 0.5. All right, do me a favor if you didn't do it already. Write the word vertex above maxima. That way those two words mean the same thing to you. It's not, oh, find the maxima or the vertex. All right, let's see what we have here. We have our X-Intercepts, where the profit is going to be 0. We have our vertex, 0.5 is a price. That will give us the maximum profit, in this case, $2.25. Anything else they're going to ask us about this? No, I think those are the main things for this problem. What would the Y-Intercept be?
0, 2.
Yeah. I know because your computer gives it, you can have it. But again, for the purposes of the profit problems that we're going to get in just a moment. Not completely necessary. But again, if you want to put it in, it wouldn't hurt you. All right. Now let's hear the real deal one. You're going to want to do it twice. Not only will you do it the first time you get the original picture, they're going to have you do a second version of it where these numbers are going to change. In other words, they're going to shift it maybe to the left or shift it to the right. So let me do a shift, and I'm going to ask you, what does that shift mean? In other words, let's say somehow this problem got changed, and the new X-intercepts were at, let's say, at 1. And let's see if this one gets moved over. Let's make it shift over exactly the same. 1, 2, 3. Let's say the X-intercepts got shifted over for this problem. Let's say the rainbow still goes up, but it goes up 1 higher. Here comes the real question. What does it mean now that we have these new X-intercepts?
Why?
In the back. The fact that now 1 and 3 are the new X-intercepts, how does that change, or how does that compare to the original problem? So let me ask it this way. Hey, what does the -1 and 2 mean in the original?
The 2 points that how much you're gonna get zero.
Those are the 2 points, or the 2 prices, that will get you 0 profit. That's a no good thing. Well, what does this 1 and 3 mean if it were changed? Right, but now it's saying, instead of charging this low number to get a 0 profit, at 1 is where we would have a 0 profit. And instead of at 2 getting a 0 profit, really there should be a 4. At 4, we would have a 0 profit. In other words, the numbers are higher for getting a 0 profit. In other words, you could charge more money. You could charge $4 instead of charging $2, and it would produce a 0 profit. Now, why that's the case, we're not exactly sure, but what they're going to do is give you 2 problems. They'll give you the first one, you answer all the regular questions, the green ones, you know them. Oh, that gets you the 0 profit, the max is here. Then they say, wait, we're going to change something. And when we do, how is it different than the original? In other words, you can charge higher numbers to get a 0 profit. It is one way that it's different. The profit on this picture happens to be higher. So they're going to give you 2 pictures and just ask you to compare them. What's different between the green and the red? Oh, the red is higher. In other words, you get a higher profit. And the red is further to the right. You can charge more money to get these higher profits. Okay? But let's go ahead and do the original. Here it comes. Computers are ready. Here we go. The real deal. Go to page 61. Page 61. Computers are ready. They gave numbers that are so big and ugly that you would have to do it on a computer. Step 1, this is the grand finale. After this one, oh, thank you. So we're on page 61. The good news is, for the problem that you're going to get, the picture will already be there for the first one. The second picture you have to produce. So the good news is, this ugly picture thing, let me see if I can type it in.
It's gonna be really ugly.
Yeah, it's not even sitting on the thing.
How do
It's just really intense. It's like really intense.
Really?
Do you want to look at it? Look at it. It was so crazy. Do you want to look at it, Thomas?
It's going to start asking the questions on the right-hand side. So again, sorry about the sketch. I don't know why they chose it. Let me try and put my numbers in. But hopefully you can feel the point of the assignment, which is partly because you're using technology. They can be as crazy as they want to be, and normally you wouldn't have to sketch.
What are the first points?
We need to change our piece to... Oh, it's not.
Sorry about the picture. Is it negative 2x squared? They use P?
Oh, you have to go.
When you all type them in,
No, I used X.
did the P work?
Yeah.
You put in P, and the P's work?
Yeah.
Okay, I'm gonna do x2 just because I'm used to it.
I do everything.
Well, what was the middle term? Plus 384. Come on.
Someone has that screen.
384. I'm put X even though I know it's P minus this 155.
Yeah, the okay side. So isn't like that? I have to go all the way up to like all the way to 96.
All right. And for again for those who are not typing in, and then Roz, make sure you peek in there on Alyssa. Make sure she's not alone.
Oh, they have to go all the way back down. That's it. It's pretty easy.
Yeah, this is a crazy looking picture.
I can give you the numbers that you like, Thomas.
What did it go at the top? But again, notice once you get there,
You don't know what you wrote.
No, yeah, it's 58.
Are we gonna do performances today?
Yes.
Like, I'm ready.
No, not yet, not yet. But being ready is good. All right, so I got my picture. I'm sketching it because of 96. Did I get those right? 96. So 88.
Yeah.
So again, the point of it is once you know what you're looking for, even if they do crazy numbers, I still know what the vertex is. So when I'm asked what the vertex is, I still also know, can someone tell me what the price is that will maximize my profit? 96. What is 96 sometimes called? Line of symmetry. And it has the formula is going to be x equals a 96. So you can see what I'm saying. We've gone through some of the other ones, so when they put in the real context, you're able to still use the numbers. For those who've gotten their picture and sketch, on the next page is where they're going to start asking you the questions that go with that. So see if you can start writing those in. Hopefully you can feel that this assignment isn't the hardest one there is, now that we've kind of gone through pieces of it. If you're not sure about something though, and you don't want to ask me, check with someone next door to you, see what's going on their paper while I'm trying to put something on my paper. Yeah, the next page should be asking you to start filling in. The one right next door to it? If you want to peek ahead, you can, though it's going to, you don't have to. Say again? That is circle, yes. All right, so let's see. What were the zeros on this one? The X-Intercept?
58. 58, 0, 134, 0.
58, 138?
58 and 134.
134.
I'm just putting in any numbers. For those who are sketching, look what I just did. The 58 to 134, I didn't scale it or anything. I just did it. And up here, I'm just going to go to max, which was, what was it, a 96?
96 and 2,888.
So look, say the numbers over here.
2,000.
288.
888.
Is there a zero?
3 8s. There you go.
So for those who are sketching, like, okay, how am I going to sketch that picture? If it's a crazy picture, just, you know, put in, like I'm doing here. And then I'm going to,
Wow.
okay, it's a little ugly.
Same.
I should have just kind of rounded it. So hopefully get, oh, what if you put your picture down low, like you didn't go all the way up? That's fine.
I made mine really thin too on my photograph.
If you made yours really thin, that's fine.
Wow,
I really did copy it. Like,
All right. On the next page, though, is where you start answering the questions. Please fill in the answers to those questions.
what if you filled them out?
Then you're
That's
one
good.
step ahead of the game.
All right.
Okay.
Are we
We
doing
got
the
our
back or no?
X-Intercepts. We are in just a moment. But let's all get these parts in here so we can all share them. All right, again, someone say what one of the X-Intercepts was?
The X kind.
58. Thank you. Someone different, give me the other one.
1340 or 0, how many say?
All right, what was the maximum on this guy?
96 to 88. 2,888.
Again, do me a favor, put down vertex. Now, again, I didn't ask you to, let's see if they ask it. On these, do they ask us what they mean?
Yes.
Okay, line of symmetry was x equals what?
96.
96.
Okay.
Here it comes, here it comes. Explain what the X-intercepts have to do with the price and profit. What are we putting there?
What are we putting, or what did we do?
What did we put, or yeah, what should be there for D?
Oh, both points are the prices where there is no profit.
I like that. Both X-intercepts or both points. And I'll put X-intercepts or points.
Is that a 96 or is that a flipped candy cane?
Both X-intercepts or points.
Alright, watch.
Wait a second.
How did you say that, Carlos?
Well, I'm writing it different. I'm putting both points indicate the price that generates zero profit.
How do we say for both X-intercepts, both points are prices.
So instead of doing a different, instead of like the end of the unit.
I'll put that produce
we don't remember.
zero
We
profit.
have to pay for learning this. This might be complicated.
To tell what the line of symmetry is, when you get your vertex is actually the dot at the very top, which also happens to be the point that would cut it in half. So whatever the x-axis, or the x coordinate is of that, he always tells you, okay, where is that rainbow? Let's see, did I draw a picture? Where that rainbow is going to cut it right in half. So there's a 96. So that's kind of how you always know. So 96 is on that halfway point. All right, here comes the last piece of this puzzle, and then we'll see, have you stare at it, look at it, see if you want to discuss any of it, and then ultimately we'll give you that performance task. Remember I said they're going to give you a second equation. Here comes the second equation on the next page. This guy here, not you, but this guy here. Put a star next to that equation, please. Put a star next to that equation that's after E. Oh, I'm sorry, we didn't answer. I'm sorry, we didn't answer E. Oh. Well, let me ask a question. What is the price that would give the maximum profit? 96. Okay, so they asked it differently. In other words, the line of symmetry.
Is that the question based off the other one?
It's the one we just
Oh,
did.
snap.
Yeah.
We're right now. Are you gonna give like the
For question E. Question E should be on the back of the page.
Oh, I see.
All right. So question E is on the back of the page. 96 comes from, of course, that 96, comma 288. That's where that's coming from. The line of symmetry tells you what is the number that gets the company the most money back. And it's always that middle line. Again, if you're looking at it as a picture, the question they ask you is how do you get to the very top of the hill? That's what question E is asking you. If I'm at 96, 96 gets me to the top of the hill. The problem with these is they have so much information that somebody might get part right now, take a hand, and then miss part of the other part.
What if you don't want to go to the top of the hill? What if you want to just like go a little slow?
Start on this profit question. I'm going to read what it says, and then we'll see if we can answer.
You type it in the decimals?
It says here, hey, Mary knows that the cost of steel for the table legs is about to go down. I don't know who told Mary that, but she knows it. This means it will be cheaper to make the tables. I mean, she doesn't have to charge as much. Let's see what she does. The new equation is in factor form. In other words, before you type in, pause. Let me ask a quick question. Just looking here, can someone tell me what the two zeros are going to be? Just looking at the
46 and 124.
46 and 124 are what they're going to be. Because whenever it's in factor form, same number.
Different side.
But now punch it in. Still punch it in. Let's see if it does in fact land there. I don't know if the new picture is going to be bigger than the last one. Punch mine in and see what it's producing.
A noodle? A noodle?
A noodle.
They're all super thin.
Oh, so
They all look the same like that.
Is it as tall? Is it shorter?
It's taller.
Taller. That's good news, because it's taller means we'll make more of what?
More money.
Uh-huh.
I'll be able to make more money.
So is y equals what? Y equals what?
Y equals.
I didn't do y equals, I just did the 2x.
Y equals
Negative 2.
X minus 46, parenthesis, X minus 124. Where did the parenthesis come from? Oh my gosh, I'm so tired. See, he understood.
This guy right there. Really? I wonder why they would
I'm gonna be real with
wonder
you.
why they wouldn't make it in such a way that it would make a better picture.
Do you have to put y equals? Because I didn't, it came out.
If you came up, then you're A-okay.
Y equals last time, and it didn't come out, so.
All right, so on this new guy,
I'm just.
uh-oh.
The function.
Conjunction, junction, what's that?
Is it a 94?
No.
Did I put something in wrong?
You just gotta take off the first one.
Yeah, there you go. Boom. Boom.
Okay, I erased my first one by taking out the circle in the case that you have issues seeing both. But I don't see.
No, oh, what are you doing? No. 85.
All right. All right.
So they can charge less, but the maximum profit would be higher.
Did you hear what Ron was saying? Say that again, please.
She can charge less, but the maximum profit is higher.
It's called follow.
So in this case, she can charge less. Her LOS, her line of symmetry, is 85, but her profit is even higher than before, because of course the price of steel is lower. But where are the questions so I can know how they're asking you?
It just says describe how the graph has changed from the original equation.
And I just put it's taller, has a bigger profit.
All right.
I'm not doing all this.
So in this question here, they're actually in this question here, they're asking you to compare just the actual pictures. So it's taller. A higher vertex is another way of saying it. The X-Intercepts, I don't know how they fall. Do me a favor, what are the X-Intercepts on this new one?
46.0.
All right, let's see, 46, 0, and
124. So the X-intercepts are a smaller number.
okay. So you can see that the X-Intercepts are smaller, so they almost should have reversed the question. They probably should have put this one down so we can write down the X-Intercepts first. What was the maximum? Was it 85
Yes.
and 30, 24?
40.
Yeah.
42.
All right, 42, close. Now I recognize that this is it feels like a lot of information, but I'm starting to feel like it's the same information just repeating. So the maximum, the intercepts, we click on our picture. Now you got to be able to produce that picture. So if anyone had any trouble punching in their picture and clicking on the maximum, and then also trying to click on there, if the sketchy part didn't go on well, I understand that. All right, let's find out. What is the line of symmetry?
85.
X equals 85.
X equals 85. Make sure you write down the formula. But can you see how it's all part of the same information? All right. This is enough to get us at least to be able to take a portion, if not all of the performance task. But here's what you need to do next. Say the question asked.
It's taller because it has a bigger profit with less money.
Taller.
If they charge less for a bigger profit, that's right.
How did I know it does that?
But this one's larger vertex.
She also know how to cut
You
it.
know, Fridays and Sundays.
It's the vertex. Maximum.
Oh, so it's the.
And then Ron, you said the X-intercepts were smaller. Oops, taller. I'll put smaller X-intercepts.
You know these names that no one else knows, and
So when you answer this question,
you can literally look on your computer and compare the vertexes, sometimes called vertices, and you can compare the X-intercepts. If you write them down, it's easier to look at it and compare them. That is this 46 and 124 compared to what do we have up here? Oh, it's not up there. Compared to what we had on the other page, which was 58 and 134. You can just compare the X-intercepts and you compare the vertex.